Here's Joe.
Yes, thank you, Nicolas.
Here's Nicolas. We are both from the Digital Innovation Hub. Some of you already know us, but we are here to help the SME sector in the manufacturing field to digitize. So then after that, we had some information concerning the tool we are using. So you saw the slide. Just to remind you, it will be recorded. We have a basic chat functionality. We have a question section that is dedicated for you to interact with us. There is a poll section for us to interact with you and to ask some question about your feeling with the topic. And there is a list of all the people that are in the webinar with us today.
Thank you, Nicolas. Thanks for repeating it to me at least. And sorry again for the technical issue right at the beginning. Yeah, today it's all about robots versus cobots. We called it really for a reason, because many people believe that the cobot is only used directly cooperating with a human being. And what we see in the market, what we have seen in many good factories here in Luxembourg, is actually this is not always the case. And we like also here to demystify it a little bit. And I believe we also find some good speakers today that can help us to make the difference. We have a first poll already prepared that you find in the poll section. And from the audience that we have today, it would be interesting to hear who from you is already using classical industrial robots in your production or somewhere else. Who of you is already using cobots as well? Then most likely it will be cobots and robots. Who is just considering and who is not even considering it to use in the near future? So if you would go there and answer those questions, would help us. In the next slot after the first speaker, we will present the results with you. Now, just getting into the topic, what might surprise you in case you are not so much in the statistics about robotization on a global scale. Meanwhile, according to some international robots, more than 2.7 million robots are in operation across the globe. And no surprise, besides the high number, I have to say, is that most of them are used in automotive, but particularly important, you see also quite a high rank on metal. And as we know from our ecosystem here in Luxembourg, we have many manufacturers that are actually dealing in metal. Then looking to the installations, and that's also a bit of, in my opinion, a bit of a demystification. 73% is in those countries, and not all of those countries are known for high labor costs. So there must be other reasons to use robots. Quite interesting. Last but not least, in some countries, the density of robots per employees is quite high. 3 of them are from Asia, 2 are from Europe, at least. Also quite an interesting number. And now finally coming to cobots. Of course, cobots is a discussion and solutions you find by the larger OEMs since many years. We have one OEM present today. But the numbers are really increasing sharply. And there is even an expectation that by 26, the numbers, the installations have already tripled. And I hope that the speakers of today can help us to better understand why this is the case. And I'm really happy to introduce the first speaker, which is Paul Rivus, who is the Managing Director of FANUC Benelux. And knowing Paul since quite a long time, I know that his DNA is really about mechanical, electrical engineering, and he is since more than 20 years in this market of robots. And I'm really looking forward, Paul, to listen to you and see your presentation. The floor is yours. Thank you very much.
Thank you, Jo. Thank you, Nicola, for this very nice introduction. I hope you can hear me directly from the first time. Can you hear me, please? Yes. Okay. Super good. I would like to share already my presentation with you, and then we can start. So first, let me start. If you can see the presentation, would be great. If you can also let me know. So my name is Paul Rebus, Managing Director of Fanuc Benelux. I'm 20 years already working in factory automation, as we call it. And it's not only robots, we also are active in CNC applications, layers, but today we really focus on robots versus cobots. And I hope in the next 10-15 minutes to give you a little bit deeper insight in the industrial robots, what you can see on this picture. But for sure, also today, we want to talk a little more about collaborative robots. And when you start looking to the first page and the second page, I think most of the people here attending this nice event already directly see the difference between the two. Before going inside more the differences, I think it's good to go first a little bit in industrial robots. I don't know people attending this event, what is their background, but about talking about industrial robots, mainly industrial robots, we see that access speeds are very high. That's very simple for these industrial robots. We start from 4,000 millimeters per second, but we even can go to 11,000 millimeters per second. So this is really a criteria which is typical for an industrial robot. On the other hand, what we also see is in 100%, and I think this is not 100% correct anymore today, but today also in 70%, industrial robots are always working behind a safety fence. And on a last item, and this is, I think for sure also an important one, is what we can see is that for the industrial robots, there is a wide variety on models. You can see it on the pictures. So we start with, on the left side, the articulated. You have SCARA, Delta, paint robots. So you see that there is a wide variation of models. When I only look to our product range in our range, we have up to 150 different models. We're going up to a 2,300 kilo payload. So there is a big variety of models available from low speed to high speed. So there is a big choice which you can use for all the application. When we now dive in collaborative robots of Cobots, and maybe we can talk a little bit later on about collaborative, because today it's still collaborative robots called. But a very typical criteria for a collaborative robot is where we see that the access speed is much lower than the industrial robot. So it's maximum 1,000 millimeters per second. And that's also normal, because there we really have the collaborative item which is coming up. In most cases, the collaborative robots are not used with safety fences. And also there today we see the opposite. So I think this is something where I would like to highlight a little bit later again. This is not always the case. And what is typical for collaborative robot is, I think, is the variety of models what we see. You really see that we only have a small variety, and most of them are articulated from a lower payload to maximum, sometimes already 35 kilo. So this, I think, was a little bit a first insight which I want to bring between the industrial and the collaborative robot. But then I would like to go a little bit deeper on the main differences. What are really the main differences? And sometimes there is maybe not a real difference, but I still call it. I want to show you in some short slides, some 4 topics where you want to see, you think maybe there is a big difference, but I still want to highlight it. So if we look for programming and we go for the left, if we look to the industrial robot, most of programming today is done via, as we call it, the teach pendant. This is what you see on the picture, what the operator has in the hands. He's mainly doing teaching, programming via the teach pendant. On the other hand, when we see to the collaborative robot, and then you see a big difference is where the operating is really moving the robot by hand. And then you think, okay, here there is no operator of no teach pendant anymore needed. And I think this is the big thing, is that it's a little bit what is created in the market by the first collaborative robot builders, is that it's very simple programming by moving the robot only by the hand. But I think important to know in the background is that it's only the moving program. So it's important that you understand that when you create a program, you have the moving, but you also have then build the interface with all the peripheral, and then you still need a teach pendant. So also, and then we go to the next point, is you still have a teach pendant also for the collaborative robot. If you see on the left side and the right side where you see the collaborative, you see some differences, and I think this is also normal. Today we have a newer generation of people. They are used on mobile phones, working with tablets, and this is also what I think we as robot builders have done, especially within Fanuc, is also how can we bring this new intuitive interface over to the younger generation, make it more nicer and easier of use for these people. And then that's what we have created. And of what you see is on the right side is you really see a drag and drop interface. So you don't really start programming with lines and codes. What you do on the left side, what you really see is where we still have the older generation of teach pendant, where you still do programming with predefined codes, let me call it like this. Now, I also already want to have a strong remark is that even today, this drag and drop programming, what you see for a collaborative robot, we can also use that on our industrial robots. So this is also already possible. So if you see main differences, the main difference becomes smaller and smaller. What we also see is that a lot of programming is done offline. So most of the offline tools we have available, you can do all the programming offline, and only the small fine teaching will be done on site. If we then see another difference, and I think this is maybe still the highest main difference between the two, is a flexibility. And I don't mean in flexibility in the operation, what a robot can do, but mainly in how flexible you can, for example, move a robot. What we see for the industrial robots, they're really probably used or designed in a project, in a product, and fixed to the floor and really stand there for the next 10, 15, 20, or even longer. When we see to the collaborative robot on the right side, you see that because of the smaller variety, also the payload is less. So that means also that the size and the robot is smaller, that they also have a smaller frame needed to move. And important to understand again, and then we come back one of the first pages, is that when the speed of the robot, when you have the 4,000 millimeters per second for the industrial, or the 1,000 millimeter per second for the collaborative robot. So when you move slower, that also means that the infrastructure needed to mount your robot can be easier, can be lightweight, and it's also one of the bigger advantages for the Cobot today. If we then see for accessibility, and I think this is also something where we see today the collaborative robot has some more advantages, is that because of the low speed, no fences are mostly needed. On the other hand, the industrial robot, where we have again the high speed, the tooling is mostly not good equipped for cooperating working, so therefore we always need fencing. So the accessibility, the direct accessibility to the robot is different. On the other hand, also there today, when we look for industrial robots today, there are also already software features where you make a kind of semi-Cobot, where you can work together with a robot, but when you enter in a certain distance, the speed of the robot is always going down. And you enter too close in the work environment of the robot, even the robot will stop. And this, I think, is a big difference between the Cobot and industrial robot. A Cobot will remain working. Even when you're close to the robot, it remains working. This is different with the industrial robot. On the other hand, collaborative robot, as we said, lightweight, easy to use, and they are with the speed, they have sensors inside where the impact will be detected, where the robot will stop, and so you can work in a safe environment. So then I think all what we said before is, okay, then good, but what robot do I need to choose? And there are some small criteria which we always see coming back. And I think I have highlighted here 4 elements where we see which are important. So first of all, you start with what is the cycle time, because this is really defining for you. If you have a high cycle time, it's very unlogic that you probably will start working with a Cobot, unless you will have so many robots to reach the cycle time, but this is mostly not the case. So this is a very important topic. A little bit, the next one is in line with the first one, is the production volume. So what is the volume you will handle in a certain time frame? So these also make part of the cycle time. So these two are very close together. And a third point is the part variation, where we see size and weight. These are very defined for selection of the robot. When as we said, when you go above 35 kilo today as a part, and even with the size which have some dimensions, you cannot even use anymore today a Cobot. You really have to go in the industrial robot. And I also wrote down location, and location I more need there to clarify it is what is the reach you need? How far is the part away from the robot? So even sometimes you have a low weight, but the part is maybe 2 meters away from the robot. So you need to have a bigger robot to do this. Excuse me. Then the last one, I think this is a very, very crucial one, is do you really need collaboration? Is this really what you want to do? Because this is really defining today if you will select a Cobot or not. Honestly speaking, and I think what we saw in the market, and this is also what Jo said today, is that, and what we see in the market is, I think we can say in 90 and even 95% of the cases, most of the Cobots today in the market are not in a collaboration mode. They're working in an environment because people see it as an easy operation, easy program. We don't need a high-skilled person in the factory to do the programming. We see this different because today, and I think this is something we want to clarify, even the programming of an industrial robot today is not very difficult. It's very simple, but that's still a kind of perception in the market. But this is also a little driven by the Cobot builders today, of course, is that showing this on exhibition by the hand movement, giving the perception that a Cobot is easier to program. There is some advantage, of course, because it's lightweight, but be sure that also industrial robots are very simple to program. So this is a highlight. And then I think also 2 important things is the work setting. What is the space you have available in your factory? Do you have a huge facility and you have a huge work floor space available? Does it then mean that you need to install a big robot? No, not always. Maybe you only have a small space. And again, also in the industrial robots, we have very small robots which can be used. But the main topic, and this is something we already touched, is of course, again, the safety. Is the fencing needing yes or no? But still, also today, what we see in Cobots, and that's something very important, when you're using a Cobot or want to use a Cobot, and maybe the Cobot is safety, but also your peripherals around should be safe. And this is very, very important. So it doesn't mean that you start using a Cobot that you can say, okay, now everything is safe around it. No. So the CE clarification, to do the really CE clarification, is sometimes much more difficult than for an industrial robot. And to finalize, then for conclusion, for me is, I think you first have to investigate what do you want to do. It doesn't mean that you always need. Today, the trend is people think we need a Cobot, but I think it's important to understand What do you want to do? Can I make it safe? And do you really want to go a Cobot? And I think, again, look to the application. What do you want to do? And based on this, you can make the right selection. And I think here I will finalize my short introduction. But also what I still want to highlight is, if somebody has questions, we have a very nice inspiration center where we further can highlight the differences and where we can help you to make the right choice. Thank you.
Paul, can you hear us? Yes.
Yes, I can hear you, but there's a big noise behind. Now it's better.
Yeah, we have. I hope you can hear me well.
Now we can hear it.
Okay. Paul, a few questions came already in. You have shown the let's say, the more modern handheld for programming on the Cobot in the way that it is very different. And one question from Bastian was, is it also possible to program Cobots by use of a standard tablet or mobile device?
Today there is still a connection between the teach pen and, of course, you need to still, again, we need to talk about safety. And when you use a mobile device, there is no connection between the device and the robot. We have developed for the tablet, you can, I don't know if we saw it on the picture, maybe people can remind it. When you saw on the tablet, there is we developed a special holder behind with an emergency button. So you still have, if a person is programming something, he still has the emergency button. So today there is still an emergency button needed when you do programming. And this is something you don't have with your mobile phone today.
Thank you. Oh, you still have.
There is an issue. Yeah.
Now it's better.
Better now.
But I don't hear anything anymore. So.
Now it's okay.
Yeah, a similar question. No, not similar. I would not say that. But also from Bastian. That's an interesting question. I mean, you were clearly explaining in what cases a classical industrial robot could make sense, or where more a collaborative robot is applicable. And the question here, if I understand it correctly, it's more, could their use also be in a kind of hybrid, I would call it, so that you have certain functions where it is really collaborating with a human, but then it is doing other operations where the speed would be increased, for example, and no human around.
Yes, this is possible on both sides, as I said. So if we first talk about the industrial robot, so the industrial robot, we have the high speed, but as we said, we have some software functions which we can have on the robot, where we can work with a sensor, a zone scanner, let me call it like this, where you can define the zones. So the shorter you will come to the industrial robot, the speed will go down. So then you can still have an operator closer to the robot because the speed is down. But when you come in a certain distance, the robot will stop. So it's, as I said, a semi-cooperation there. On the other hand, when you go to the Cobot, so it's always slow moving, you always can go closer. But there's also, you can work with the software, the same software, is that you work with a sensor that when you go outside a certain zone, you can increase the speed of a Cobot to a higher level, but not to the 4,000, which the robot is moving a little bit faster than in the co-mode, let me call it like this. So it's possible to have a higher speed when the person is outside a certain distance from the collaborative robot. It is all again with speed and impact on a person. And now we only talk about speed and a person, but also when you, and that's what I said, the risk analysis, when you have a cobot, when you put it on a table and the robot is moving on the eye height, the impact here is heavier than when you have it on your arm. So this also you have to do in the risk analysis. So the speed even is lower on this height than we have it lower. So this, therefore, as I said, so the risk analysis to do for a cobot is sometimes much more complicated. And even today, we see more and more cobots placed behind fencing.
And yeah, due to the time, one last question, but actually the question is from Nicolas.
Thank you, Joe, and thank you very much, Paul, for these clear explanations. And my concern was about how autonomous could be an operator, so someone who is working with the cobots, is or she's able to by herself, program these cobots and then make it evolve during the life cycle of the production, and how they could by themselves be autonomous regarding this configuration.
In most cases, what we see, and that's what, it's not only the robot, mostly you have a lot of peripherals around which needs to be connected. And therefore, still what we see, it's mostly these companies or persons need a kind of, we call it a kind of system integrator, which help them to develop this. And I think if you only do this one time, it's very hard to do that by yourself. So we always recommend to go in contact with a kind of system integrator who have a lot of access and a lot of knowledge in their company to help you to do this. At the end, when you have all the peripherals around, and then to change the move program, when you have the peripherals, then when you change the movement, only the moving program, that's something easily done by the operator, or changing the tool and then adapt the program. That's very simple. So I think you really have to split it in two.
Okay.
Thanks a lot. Thank you, Paul. Thanks also for the really many insights you have given, also from the viewpoint of an old in the world, by the way. So thanks again, Paul, and we move to the next section, which is about the results from our poll. Nicola, you?
Yeah, to remind you, it was about knowing how much involved you are at the moment in your manufacturing process regarding the use of cobots or eventually of robots and eventually robots. And actually, what we can see is that many of you are using robots and cobots. That's kind of a surprise, a good one actually. And the other one, basically, they are not in use and not particularly considering that at the moment. So perhaps it's some of our speakers that are more in special kind of manufacturing
that can be. I mean, it's just a reflection of the audience, so we should be careful on these numbers, generally speaking. But still, it's also interesting to hear who is listening to our DIH talk today.
Clearly.
Okay, Nicola, you introduce the next speaker, correct?
Yeah, pleasure. So now let's give the floor to one of the partners of the Digital Innovation Hub here in Luxembourg, the University of Luxembourg. And let me introduce you the Professor Dr. Holger Wuchs. He's now for 12 years at the SNT, where he is a full professor in engineering science. And he'll give us a more, let's say, academic view on the topics. So, Professor, the floor is yours.
Yeah, many thanks. First question is, you can all hear me?
Yes.
Okay, good. Then I will share. Okay, I hope we can all see the slides. Perhaps a quick feedback. Okay, I see. Yeah, obviously, yes. Yeah, good morning, everybody. My name is, as already introduced, Holger Voß. I'm from the academic side of Cobots, and from the University of Luxembourg, and also the SNT, the Interdisciplinary Center of Security, Reliability, and Trust. And there I'm the head of the SNT Automation and Robotics Research Group. And my presentation today is a little bit about the programming part. Therefore, I'm very thankful. I think Paul introduced very nicely these what cobots are. And what we of course see in practice is that on the one side, sure, they are a bit easier to program, but on the other side, it still depends, of course, very much on the kind of application that you have in mind. Therefore, one thing, of course, from the research point of view, what we are now trying to apply is machine learning. That means machine learning and a machine learning approach for the engineering, because it was already said that it's a bit more than pure programming. It's also the engineering for flexible. In this case, it's a use case. Flexible assembly processes using cobots. Just for those that do not know us, the S&T Automation and Robotics Group, our, let's say, strategic research areas are in autonomous robots and vehicles, but not exclusively. We also work on space systems, space resources, Internet of Things, Industry 4.0. Let's say roughly everything that has to be automated, like also energy systems and sustainable resources. We have a team about a bit more than 20 researchers. And I think we have also some very nice labs. Some of you perhaps have already seen them. We do a lot of work in mobile robotics, unmanned aerial vehicles. We have a kind of indoor flight arena where we are doing the testing. Then we have a larger service robotics lab. And by the way, in the middle here, you see one of our service robots that we are applying currently with our partner Stugalux. I've seen they're also here in the audience, where we are applying then mobile robots, also as a kind of service robots on construction sites. And the talk here today is more about then how to say stationary robots, which are nevertheless then collaborating with humans. Okay, you see, we are on top of that. We are also working a bit on autonomous driving, and last but not least, also on space robotics, where we recently also have built up some very nice labs. Today, I would like to motivate my presentation with a practical use case. This use case is motivated by a partnership that we also have here in Luxembourg with the company Rotarex. Perhaps most of you know, or some of you know. So Rotarex is, you could say, kind of world leader in the production of valves for gas bottles, like the bottles that you have for oxygen, for medical applications, and so on. And looking at these, they are not too big, but surprisingly, at least it was surprising for me, surprisingly complicated. That means one of such valve contains about more than 80 parts. And here in this case, we have a typical case of, I would say, mass customization. That means Rotarex, they have many product variants, but with very small batch sizes. So therefore, if you remind back to what Paul was presenting with these characteristics, what is calling for a cobot, I think this is also among the criteria. That means mass customization, which also requires a very flexible robot operation. In these products, we have very challenging assembly processes. That means we have very small parts of different materials, or you could say we have parts of different sizes up to very small parts. We have very complex assembly steps. We have a, let's say, high speed, but we do not talk about super high speed, which would require then an industrial robot, but we also have a demand for higher accuracy. Here, we are also foreseeing to a certain extent real human-robot collaboration. At least here, it's not done yet, but there's a huge potential to include that, because here in this picture you see the Cobot. In this case, it's a Yumi robot from ABB, but you see in the background also one of the human workers sitting. And for sure, this production could profit indeed from at least partially real human-robot collaboration. Yeah, that means some of the assembly steps could be done even better by humans. Yeah, some of them by robots. And the question then is, even in the programming, how to foresee or how to program already these interaction. Yeah, and finally, it's about then the robot systems engineering, because as it was already said, here you see it's more than just only the robot. The robot also has a kind of mechatronic system around, and very often, of course, in this case here, you also need especially the sensing part. That means you have a sensor system which needs to detect and to identify the parts that the robot should handle. So the basic goal here is, that means you can imagine now if you would switch from one product to another one, there would be a kind of continuous, new robot programming and new robot setup. Also taking, for instance, the vision part into account. And the core research question here: can we support that? Let's say robot engineering and the programming, even for non-experts, non-robotic experts. By machine learning. So that means our approach, roughly speaking, contains two parts. So one is considering the vision system, because the robot has to detect. I mean, this is also one part here, or that you have to understand here. Flexibility means a lot of parts, they are just poured on a pallet. And they're not coming each time at the same point where you can always pick them. They are just poured on a pallet, and then the robot really has to detect them. And they are, let's say, even this pick and place is then starting always from different, from different initial places where these parts are. That means, first of all, it's important to have a vision system in this case. That means what part to pick, where to pick it. And especially for the robots, also to see, where are the grasping points. And that for a huge variety of more or less challenging things, more or less challenging parts. Then on the other side, we have the programming part, or the moving part, where we have, first of all, the overall assembly task, which needs to be planned. And here we are trying to apply learning from demonstration. That means it's a bit like, compare it with a bicycle. That means if you would like to ride a bicycle for the first time, perhaps we all remember when we were children, the first thing that you could do as parents, for instance, you sit on the bike and you show it to the children how you would do it. That means, and then they look at that and then they try to learn from that. So this is the idea of learning from demonstration. And examples here is how to pick and place, how to insert, for instance, a really small O-ring, how to pack in hole, and all of these things. And then finally, when it comes to the real motion planning, then the question is on that level, how to do this most efficiently, and also, as I said, with the required speed and also accuracy. Okay, first the vision part. I think here, because the nice thing with this application is that it covers a bit all the different possibilities of machine learning. What we are applying here for the vision system is deep learning or supervised learning. That means the idea here is we demonstrate these objects to the vision system, however, in a labeled form. That means we always tell the system that should learn, okay, so here this is the part, but if you see the part in this, under this aspect, the point where you have to grip it is here. And if you would do that with the real object, of course, then it would be a huge effort, because you had to do thousands of images that you perhaps take from the real object. You have to manually label that, and this is, of course, very time consuming. That means what we are doing here is that we try to automate that, or that we automate that. That means what we first do, we create a photorealistic simulated object that you can see here in the middle. And if you compare the real object with this one, is that in the meanwhile there are tools which give you a very realistic simulated object. And then it's, of course, much, because this is all digital, then it's much easier to label that. And then you have all the inputs that you need for deep learning a neural network, yeah, which is then learning from that. That means from the objects plus the labels, yeah, and then at the end, yeah, the vision system is then able to detect, or to estimate at least the pose, which meaning the position and also the orientation of our workpiece, in order to transfer that information to the robot to pick it. Yeah. So second, is then now we come on the other side to the motion part. Yeah. What we are applying here is, as I already said, is learning from demonstration. That means we have a human demonstrator. Of course, there are different ways to demonstrate that, but we have a human demonstrator, and then the robot should learn from that demonstration without any need to hard code very, very complex tasks. From a research point of view, what is really interesting is then how to learn also this human robot collaboration. That means just to see or even to detect which are the subtasks which are performed by a human and which are the parts that should be done by the robot. Of course, one idea is to somehow to give additional information then to the learning system during the demonstration. The subtasks are then, or let's say the learning is using a tricky thing which is called in the literature, it's dynamical movement primitives. That means it's a bit like, assume you would like to follow handwritten letters. Yeah, let's say all of us would write the letter L, and of course in a slightly different way. And of course, behind that, there is your typical kind of how you are moving the pen. But if you then really apply that, you would always start on different pieces of paper, on different positions where you would start and so on. That means here these dynamical movement primitives can somehow be configured, to imitate the generic part behind the motion. Yeah? And that means finally at the end, this allows us just to apply this, to generalize. Yeah? That means we always do the same kind of motion, for instance, taking a part here and putting it on another point, but it's independent where you start from. Yeah? And then finally, if this is done for a kind of fine tuning, we are then also applying reinforcement learning. That means this is a third possibility of machine learning. I will just very, very briefly show that in the next slides. First, this kind of learning from demonstration. How are we doing that? Here we really profit again from the Cobot, having cobots, because as Paul was already explaining, you can switch them into compliant mode, and then you can take the robot arm and you can move it. Yeah. So and then we are somehow by that way demonstrating the tasks, and we record all of these data, and then we generalize. That means we learn that, and by learning we generalize. And as you can see, then in the lower part, the robot can then, finally at the end, replicate this motion, but in a very flexible way. Yeah.
Holger, you have 1 minute, please.
Yeah. It's just the last slide, so I'm done.
Thank you.
So another part, or another possibility, because here it's a bit about the possibilities coming from machine learning, is reinforcement learning. So reinforcement learning is a bit like, take the bicycle example again. If you are then for the first time on the bike, it's a bit like learning by doing. That means you start, you see the effect that your action has on the bike, and then this is either good or not good. If you fall down, this is the not good. That means you get a reward. So that means in such a reinforcement learning environment, we have the robot controller, or we have an agent which tries to improve and which tries to learn. They are creating actions. That means in this case commands to the robot. The robot is moving in the environment, and then moving to another state. And then there's also a reward. That means a function. We call it a value function. Which then says, okay, how good is this? And finally, that all works in a way that given the current state, the control action should be changed or should be learned to maximize the estimated future reward. That means you try to become always better, somehow like that. The question is, of course, then, you see, it's learning by doing. The question is, where is this doing done? And there are two ways. So this can be done in a simulation, but then you can imagine the simulation needs to be very realistic, but the tools are existing, as you can see here. For instance, this is a very realistic simulation tool of the Yumi robot, or it can even be done in reality. That means you can use the real robot. The only thing is you need to be a bit careful. If you do then during the learning some safety critical things, they need to be prevented. Okay, just to summarize, I would say definitely there's a high potential of cobots, especially in this mass customization and if you have complex assembly or manufacturing processes. But I would say engineering and the programming of the cobots is still challenging. It's easier, but it's still challenging. And what I tried to demonstrate today is that there are already nice helping tools, which would then allow, based on machine learning, which would then allow a process engineer to program such a robot without really classical hard coding. This is a bit the idea behind that. Thank you very much. And I'm open for questions if there's still the time.
Indeed, there are a few questions, Holger. The one is quite interesting because it goes straight to the DNA of the SMT. You have the team that is indeed working on computer visioning, and you have your own team researching on automation and robotization. Can you explain how you collaborate together?
Yeah, I would say taking the computer vision part. So first of all, of course, we collaborate. That means here between the teams, it simply depends on the tasks. That means here in my group, of course, we also have some knowledge about computer vision because we simply need that. If you would like to program autonomous robots, a key part is the sensing. That means we also have in the team already experts dealing with computer vision. It means here, if we talk about the different groups, the key question is then, are we talking about totally new computer vision algorithms? Then, of course, we also have the experts here in SNT, and then, of course, we collaborate. If it's more about, okay, applying then computer vision to given problems, then, for instance, if it's about the robotic problem, so to speak, or the robotic task, then we also have already the knowledge in the team. So therefore, we are also flexible, but it really depends on how deep we do need to go into these into the research parts, I would say.
Okay,
but in principle,
for the sake of time, there are two other questions. If you do not mind, please answer them in writing. And I take over and we move on because of the time constraints.
Yep.
Thanks, Holger. Very interesting to listen to you.
Thank you.
Let me just start the next part.
Preview of the year.
Yeah. So we come to our sneak review, and I'm really happy to introduce Jan Kniphoff from the company Wandelbots. Actually, it's a startup operated out of Germany, and I will not disclose by myself too much because it's all about Jan to explain what Wandelbots is all about. Jan, the floor is yours.
Thanks a lot, Joe. I hope everyone can hear me loud and clear. And if that is so, then thanks. Then I will share my screen. Just give me a second, please. So, and now all of you should as well see the presentation. Okay, perfect. That sounds good. Okay, then hello everyone. My name is Jan, as mentioned from Jo, and I'm working for the company Wandelbots. But first of all, thanks a lot to the to the previous speakers. It was really interesting to get an overview. And I'm as well very happy that our company has the opportunity to be part of such a great event, and that we have the chance to show all of you our solution. So just to have a quick guideline, in the next 10 minutes, I will start with a short introduction of the company, and then I will continue with our product, the Wandelbots teaching solution. So back in the year 2011, our 7 founders realized during their studies at the University of Dresden that robotics software is fragmented, it's based on an old technology, and is the most relevant barrier for automation across industries and private lives. So out of this reason, Wandelbots was founded in the year 2017 and is a German company based in Dresden with round about 180 employees working worldwide. So Wandelbots democratizes robotics with easy-to-use software. So we unite and empower everyone, regardless of education, experience, or social backgrounds, to work with robots in completely new ways. So on how this can be done, I show you next with our product, the Wandelbots teaching, which is fast, simple, unified compared to the conservative way to program a robot. So I would love to all you be welcome to our way to automation with no-code robotics. So let me start with the first question. It's more a theoretical one. It's like, how many robots will you run in 3 years? So when we look at the market, as we can see, there is a major growth of cobots or industrial robots in the production. And therefore, we have like a lot of different factors. So one example is, of course, when you look to the future, it's the labor shortage. Then as well, you have like a lot of repetitive work. And just for a second, just imagine a world where people focus on their creativity and give monotonous work to robots. And also as well, small, medium enterprises or companies, they want to scale up their production, speed up automation, and stay flexible even down to batch size 1. And as well, it comes along with the planning of staffing, or at least making costs more efficient. And these are some reasons why small, medium enterprises, companies want to switch to automation, and as well create more value for the employees. So with all these topics, we do speak about the future, and this comes along with the usage of robots in the field of automation. And there is one thing that often scares companies away from the subject robots. And that's the question, how many of your employees can work with robots? And when I talk about work with robots, I mean as well set up a robot or even program a robot, or at least work with it on the shop floor. So these are some thoughts that comes up, but actually there are many more. So right now you need a robot programmer for the robot automation. So you need experts, and these experts are very rare on the market. And as well, there are many different kinds of brands, robots, and most important, every single robot manufacturer has their own specific language. So, and as well, when we speak about the companies, they really want to have a return of investment. So right now it doesn't pay off for small batch sizes. And as well, the training for the employees to get in touch or to learn how to program takes very long. So our goal is to make robots accessible to all employees in the production. And I also, as well, say not even to make it accessible, we really want to enable people, regardless of education, experience, or social background, to work with the robots. And how this can be done, I'll jump into our product in our Wandelbots teaching solution. And it is a symbiosis out of the tracebin. You see it up here. This is an intuitive device for all applications. And as well, but the core of our solution is the software with the associated app that comes on the tablets. So, and we dig a bit deeper into the Wandelbots teaching. So the whole process of teaching a robot works quickly and easily in 3 steps. So as easy as it is, first step is we demonstrate the robot what to do. Next step is we edit in our software afterwards everything. And third step, you just run it from the robot controller. Because with the Wandelbots, you export everything you did on the Wandelbot solution or teaching. to your robot specific language, and then just run it from the robot controller. And before I go more into detail, I would like to show a video. So, and I hope everyone can see it so far. Perfect. So, and this is the first step. You have here the input device, the trace pen, and you, in the first step, you demonstrate the robot what to do. And the second step, you edit it. This is our software, and you can see exactly the path that we created or demonstrate the robot with all the single points, and you can just edit it in the software. And afterwards, you just run it, and the robot will do it after you export the code. And then here you can see it with a short input in the welding process. So then we dig a bit deeper into the process. And as you can see here, you take the trace pen, which is the input device, and you show the robot directly on the workpiece what to do. For example, in this case, a new weld seam for the robot welding process. And how this is possible, actually, we have like built-in sensors in the trace pen for the orientation and the speed tracking. You as well have on and off functions, and you have an one-on-one recording directly on the workpiece. And you can easily set up single points, or you can even record a complex path. That's the first step to demonstrate. The second step is to edit, and the editing of the path, you will do it on the intuitive, easy-to-use graphic interface. It's a 3D simulation of the digital twin. As you can see here, here's the digital twin, and you can change perspective, and you have all the 3 axes, X, Y, Z, which are colored to guide you through the whole software. And you can afterwards edit the speed and the orientation, and as well, you can do also the input-output signals, like arc on, arc off for the welding process, for example. And the third step is, and last step, just export the code into the robot language and then run it from the controller. So, but also our future vision with BundleBots, we are constantly in an advancing process. So we want to cover in the future all robot brands and all application, just to combine everything under one language. And for the application, as well as welding, inspection, gluing, and everything that's going on with this one. And just to give a current, just to give an overview about what we are capable right now and what we have already fully integrated. We have like the Cobots on the other side with the universal robots. They're fully integrated. On the other side, when you talk about the industrial robots, we do have the Yaskawa. And as I said, it is continuously improving. The integration is ongoing right now with different types of Yaskawa. And as well, the new one is the Fanuc. And we also have the evaluation ongoing with different brands like ABB, Denso, Kuka that might come and will come in the future. And as well, we have like the different welding suppliers like EWM, Lorch, Miller, Lincoln, and Furniers. So this was so far from my side. This is the BundleBots teaching, and just to summarize, we really want to enable everyone, regardless from the background or experience, to work with robots in the future. So thank you very much.
Thank you, Jan. Very interesting. I hope you can hear me.
Yes, I can hear you.
Yes, okay. The sneak preview doesn't include a Q&A section, but please feel free to ask your questions into the question area, and Jan will continue to answer in writing to you in case there are questions. Let us continue as well then with our last part of today. But before going there, first of all, a big thank to all the 3 speakers. And I think you could also see a bit the red line that we had today, coming and starting with a very experienced OEM and a very experienced speaker like Paul, who is very long in the industry, moving towards research and how research is collaborating in the field of robotics, but as we have heard from Holger, also in the field of computer visioning with the industry here in Luxembourg. And last but not least, also in our opinion, a quite interesting solution from Wandelbots that can really ease and overcome the hurdle of programming and basically automate it so that it is really very easy to do for many people. So thanks again to the three speakers, very much appreciated and very interesting. That concludes now the episode number 8 for this year from our D-IH Talks. And overall, just to share that we had about 800 registrations this year for our webinars. It's a monthly thing for those that don't know. And we had about 450 participants by year end in our webinars. And we will surely continue, hopefully with a bit less of technical issues. Nicola, Smart Manufacturing Week.
Yeah, another important event that we participate to this year was the Smart Manufacturing Week in June. So 2 or 3 days this year. It will be more the coming year, but it will be surely once again a great occasion for all the community. So from the manufacturer to the provider to the construction sector also, and all the actors related to sustainability, to meet at Lux Expo the Box. So during the week coming from 5 to 9th June. So save the date and we'll keep informed.
Okay, one other initiative for us is certainly the meanwhile well-known D-IH on Tour event, where this year we visited 9 zones industrielles. We had interesting factory tour, very intense and interesting discussions in the bus. A lot of connections were made between research, providers, OEMs, system integrators, and of course those companies that are actually producing in Luxembourg, and it had also quite some nice media impact for us. And all this boils down into our mission, Nicola, correct?
Yeah, exactly. Typically, what is our mission in a nutshell? So it's to combine all the competencies that you could find at an academic level, from the provider side, to help to enforce the manufacturing industries here in Luxembourg in the path of their digitization. So this year we were mainly focused in the country itself. Next year we will enlarge this collaboration. So keep in touch with us. Nice things to happen.
Yeah, and we do that to help you at the end of the day. It's not us trying to teach you, we are trying to build up a nice dynamic ecosystem, connecting you and also making sure that you find interesting events that are hosted under the Digital Innovation Hub. And therefore we have built a really little survey, we have to say, where we like to gather again your feedback. It will also be announced with a mailing activity next week. But please, in order to influence us on our program for next year, please take the 5 minutes and answer those questions. Most of it is really about what topics we should, for example, cover in our webinars next year. So this is a chance for you to give your feedback and influence us in what we are going to offer next year. You find here the link already shown, and thanks also to our Marcom department that is not visible at the moment, but doing a lot in the background to keep these webinars ongoing and successful. Today, I have to say that shows also how dynamic it sometimes is. Today we had more than 80 registrations, but less than 40 participants. But we had also webinars with more than 130. And that shows already that we need your input to put the right program together. So please take the 5 minutes, would be great. Thank you very much. That's it, I think, for our DIH talk in 2022, Nicola.
Yeah.
And I would say thank you.
Thank you, Joe.
Thank you,
Thank you all.
audience, for joining us and rejoining us also next year. We wish everybody a nice seasonal closing, a safe move into the new year, and see you again. Cheers.
Cheers.